This lesson is on balancing chemical equations. So when balancing chemical equations, it's key to keep in mind that you can only adjust the coefficient, but never the subscript. When you change the subscript, that changes the whole element. The first step in balancing chemical equations is to balance the elements that only occur once on each side of the equation first, and then you can balance the lone elements last. Coefficients should end as a whole number and always reduce your fractions. You should include states of matter on each compound in parentheses. So ionic compounds are always solids, ions are always aqueous, and water, depending on how much energy is present, is either liquid, gas, or solid. To determine the states of matter on the periodic table, it's key to have this reminder. White means that it's a solid, darkly shaded means that it's a liquid, and lightly shaded means that it's a gas. So when looking at the periodic table, the white elements are solids, the darkly shaded ones, like these, are liquids, and then these right here, the lightly shaded ones, including hydrogen, are gases. So some examples of balancing equations. When balancing equations, you have Na plus Cl2 and NaCl. You notice the subscript on Cl on chlorine has a 2. Then you want to put a 2 on here to balance the chlorine out. Then you have a 2 in Na, so you want to balance that out too. So you put the 2 over here. This is the whole balanced equation. 2Na plus Cl2 goes to 2NaCl. So in this chemical equation, I started off by balancing the hydrogens. You put a 10 on here with a subscript of 2. So since the subscript here is 10 on the hydrogen, you put a 2 here. That balances out the hydrogens. Then for the second step, you want to balance out the C's. So if there's 8 C's, you put an 8 here. That balances them out. For the third step, you want to have the same amount of oxygens on one side as the other. So with 8 times 2 is 16. With the 10 oxygens is 26. And 13 times 2 is 26. So there will be a 13 as the coefficient for oxygens. This is the entire balanced out chemical equation. 2C4H10 plus 13O2 goes to 8CO2 plus 10H2O. When given problems like this, you need to first write the correct chemical formula, and then you want to balance out the entire chemical equation. So in this, it tells you what it is. Liquid carbon disulfide reacts with oxygen gas, producing carbon dioxide gas with sulfur dioxide gas. Here, all the states of matter are already mentioned. Then you just write them out. CS2 plus O2, CO2 plus SO2. Remember to write the states of matter in parentheses. So when you're balancing this out, you first want to start with the S. So there's a subscript of S here, S2. So you want to balance that out and put a 2 here. Then you want to balance out the oxygens. So you have 4 oxygens and 2 here. So that gives you 6 on this side. So you only have a subscript of 2, which is 2 oxygens. So you need to have 6, so they're both on each side. So you want to have a coefficient of 3, because 3 times 2 would be 6. This is the whole balanced out chemical equation. CS2 plus 3O2 goes to CO2 plus 2SO2. Now for the final example, you first want to start with writing out the chemical equation if it's not given to you, which is Al plus Cul2 goes to AlCl3 plus Cu. The first step you want to do is balance out the Cl's. So there's a 3 subscript here and a 2 subscript here. You want to balance them out and give you 6. So there's 3 coefficient with a subscript of 2, which is 6 Cl's. If there's a subscript of 3 here, you want to put a 2 as your coefficient to balance out the Cl's, which should have 6 on each side, which you do. Then you have to balance out the Al's. Because you have a 2 here as a coefficient, you need to have a 2 here. So now you have them balanced on both sides. Then once you have that, you want to balance out the Cu, because you have a 3 on front of the Cu here. You want to have a 3 as a coefficient here as well. This would balance out the whole equation, and you have 2Al plus 3Cu Cl2 goes to 2AlCl3 plus 3Cu. The end.